Example 1b, sketch the graph of y equals 3 over x. So this is actually y equals 1 over x, stretched by a vertical stretch by a factor of 3. So if you had to describe the transformations, this is a vertical stretch by a factor of 3. So stretches are not going to change the asymptotes, so we're going to draw those in. They're going to stay on the axes. And now we're going to see what happens. Now, when we're first learning something, we start off with a bit of a table of values. So I'm just going to sort of choose x values that would make the most sense to use. So an x value of 1 would be good because 3 divided by 1 would be easy to plug in, and you'd get 3. I could use 2. 3 divided by 2 is 1.5. That's all right, but I know a guaranteed point that's an easy one would be to pick the same number as the numerator. So I'm going to choose 3 because 3 divided by 3 is 1. So I always use those as key points. I always choose x equals 1 because a divided by 1 will be the a value. And I always choose the a value itself because a divided by a, in this case 3 divided by 3, will always give me 1. So along here, we're going to put in our scale. I realize I don't have a scale here. I'm going to backtrack because we might refer to that one. So we're going to plot the point 1 and 3, and then we're going to plot the point 3 and 1. You've got 2 points. You know what approaches the asymptotes. You're fine. If that space between these 2 points is too large, you could check some more points. Like we said, 2 would have been at 1.5, so I should have that a little bit lower. I'll kind of make that look a little bit lower than it is. Okay, same thing would happen down here. This would then be, and you can fill in your table if you wish, -1 would be at -3. So we're going to be down at -3, and if you plug a -3 in, that's going to be at -1. So we're going to plot that there, and we know that these are going to connect through here. So rather than filling in a table every time, I just use sort of a counting strategy. I know that, so we use this as 3. I know that every time I go x equals 3, it's going to be 1. So really, I'm going, if a is 3, I'm going 3 to the right. I always, of course, have to go up 1. You can't put a point on the asymptote. And then I'm going to go up, I'm going to go over 1, up 3. So here, you're going 3 in both directions. If you think of the corner of your asymptotes, you're going to go 3 this way, and you're going to go 3 this way. Of course, the points aren't on the asymptote, so they're 1 away. So we use that strategy when we're looking at the next graph.